Okay, so we're still inside this section here, and I want to move on to the second part of our review of JavaScript, which is to look at the behavior side, or the representation of logic. The lab accompanying this set of slides is this lab over here. So if we go into the slides, I suppose I should just ask, are there any questions from the last day, arising from the last day? No, okay. So we're still on the fundamentals of JavaScript. This time I want to look at the way we structure behavior or logic. And it's all about functions. So I'm saying functions are the unit of composition for logic or behavior in JavaScript. In ES6, there were two ways of coding functions, function declarations and function expressions. I'll show you examples of both of those in a minute. We also had this odd thing called hoisting, which isn't really relevant any longer, I think, but just for the sake of completeness. The idea with hoisting was, even though you might declare a function low down in your source code file, you could actually invoke it before its invocation. Sorry, you could invoke it before its declaration, which seems odd. Like normally you think I have to declare physically in a source code file, I have to declare a function first, and then later on in the same file, I can invoke it. But you could actually reverse those around. And the reason you could do that is because of this feature called hoisting, which meant that at a runtime, when your source code file was loaded into memory, all the function declarations within your source code were kind of gathered together and hoisted to the top of the memory location. And so that's meant then that your invocations followed on from the declarations. It doesn't really apply any longer, but it was just an odd characteristic. ES6 then, you can still have function declarations and function expressions in ES6, but ES6 in addition introduced arrow functions, and really all arrow functions is a simplified representation of these two up here. It's just a kind of cleaner syntax, as we'll see. And there's also a shorthand form of arrow functions. From day one, there's been this notion of anonymous functions. Obviously, you might think when I declare a function, whatever method I use, I have to give the function a name, and that's true. But you can actually have functions that have no name associated with them, and that's what we refer to as anonymous functions. You might think they are rarely used, but in fact, they're used quite a lot, and we'll see examples of them today, and you'll be using them quite a lot throughout this module. So before, I've lots of examples accompanying these slides. So the examples you will get in the lab associated with this set of slides. So I have them available to me here. So I'll just pull them into VS Code. And it's the same kind of format as the last day. Just get them first. So again, I've got a bunch of JS files, and I've got my index.html, and I'm going to be using my live server as I was the last day. So I'll start up my live server. And again, we're not really too interested in the actual web page. What we're interested in is what's going on in the developer tools console. And you'll be familiar with this approach that I'm using now. So here's the first script that I want to look at. Sorry, this one here. And it's referring to this JavaScript file here. So we'll quickly scan down through it. I've just got examples of function declarations, function expressions, etc., etc. So again, I've got a me object. It's a much smaller object this time. It just has a name and a gender property. I've got a her object with a name and a gender property, and I've got a here object with a name and a location property. So there are my kind of data that I'm going to be using. Here's an example of the function declaration. So it's the keyword function, followed by the name you want to give to the function, followed by the parameters for that function. Remember now, JavaScript is dynamically typed. There's no notion of associating a type with a variable. And just based on what the name that I've given the function, it looks like what this function does is it takes this object and it determines whether the object represents a person or not. Okay, so it's only one line of code in the function. That's just coincidental. And you can recognize this in the last. So the way I determine whether this object is a person or not is I check to see if it has a name property and it has a gender property. And if it has the two of those, then I'm happy to say that it represents a person. So it is just normal logic and. So this overall function returns a Boolean, although we can't actually state that, again, because of this dynamic typing. But for now anyway, this is just representing function declarations. And I'm invoking the function here, and I'm invoking it here as well. And in the first case, I'm invoking it with the me object. And we saw above that me does have a name property and a gender property. So I expect this particular invocation of the validate person to return a true. Whereas in this case, I'm passing it the here object. And we saw above that the here object notionally is representing a place. It doesn't have a gender. So I'd expect this second console.log to return a false, and let's just confirm that. So that's my true and false there. That's function declarations just from a syntax point of view, and it's really only the syntax is all I'm interested in covering here. And in many cases, I'm just reminding you of this. That's function declarations. Here's function expressions. The difference here is that I'm actually assigning the function to a variable. Notice I'm not giving the function a name here. The net effect of this assignment statement is that I am effectively declaring a function with this as its name. So that's going to be the name of my function. So if I want to invoke this function here, this is the name that I use to invoke it. What's this function doing based again on the name I gave to it, which hopefully is meaningful? I am adding a middle name to a person. So the function expects to receive a person object, and it expects to receive a string where the string represents the middle name that I want to attach to that person. The person may already have a middle name, in which case I want to give them a double barrel middle name, or they may not have a middle name, in which case I just want to include a middle name. And we can see above from our two objects, I purposefully, the her object you can see already has a middle part to their name, whereas the me object doesn't. Okay, so I've got the two kind of use cases, if you like. But from a function declaration point of view, and the other thing that I'm doing inside the function, which kind of would make sense, is first of all, check to see, is the first argument, is it actually a valid person? Because if it isn't, then it doesn't make much sense to talk about adding middle names. So I'm reusing my validate person function from earlier on. I'm also showing you here how to throw exceptions in JavaScript. And we know what the notion of throwing exceptions means, given that you come from a Java background. So I don't need to explain what this is all about here. Obviously, if it throws the exception, then it doesn't execute the rest of the code. Down here, what am I doing? I'm checking to see, essentially I'm checking here to see, does the person have a middle name at the moment? Now, the way I've actually coded this here is, to be honest, it's kind of old style. When I go person.name.middle, equals undefined, that effectively tells me that this particular person does not currently have a middle name. Remember, I told you that if you look for a property in an object, in this case, the object we're interested in is the name object. If you're looking for a property and the property doesn't exist, then that expression evaluates to undefined. And that's really what I'm doing here. Another thing is the JavaScript has both the triple equals operator and the double equals operator. The double equals operator is ES5. The triple equals is ES6. The short thing to remember is never use a double equals operator. It's not as safe as the triple equals operator. There is no case where you should use the double equals instead of the triple equals at this stage when you're writing JavaScript. The other way I could have written this code, as I said, this is kind of almost ES5 type code. I could have written this using the in operator, as in I could have went middle in and then get rid of all of this. In fact, I probably should have written it like this really if it was, as I call it, modern JavaScript. And I really want to evaluate the not version of that. So I'll just wrap all of that and go not. Okay, that's the exact same as what I had now. This is, as I say, a kind of a more modern way of writing it. Either way, if the person currently does not have a middle name, which is really what I'm saying here, then all I'm doing here is essentially just adding, all I'm doing here is just adding a middle property to the name object and assigning it to whatever was passed into my function. Otherwise, I'm extending the middle name that already exists. So that's what the plus equals is doing there. And so if I do, oh yeah, and I just decided to return true. I'm not returning anything useful. When I invoke that method, which I am doing many times here, I have to wrap the invocation in a try-catch block. And we know what try-catch blocks are from Java, and they have the exact same function or the exact same purpose in JavaScript. So I don't need to explain that, I'm assuming. Just pause for a second because I'm rattling through it, mainly because I think you have JavaScript previously, but I'll just pause for a second anyway in case there are any questions.
All good.
All good. Okay. You can see here. So these three, console. What am I doing? I'm console. Am I console logging? Oh yeah, console logging. Me.name and her.name after I've done these two. So that correlates to these objects here. Okay. And again, you can check that yourselves in your own time. The reason I've commented out this line here is if I call add middle name to the he and pass it the here object, then because here is not a person, my add middle name is going to throw my exception. And any subsequent code that I have, which I've got a lot of, doesn't execute. But just to prove the point, I comment out this, or sorry, bring it back in, save it. And there you can see the exception thrown. That's function declarations, and this is a function expression. Back to my slides. We haven't seen anonymous functions yet. We'll see them later. Arrow functions were introduced in ES6, and I'm just saying here that really all arrow functions R is a cleaner syntax for creating functions. Not that the function declarations and function expressions that I've just shown you are necessarily very kind of long-winded, but arrow functions are slightly shorter from a syntax point of view. Now, there is another purpose behind arrow functions. I'm not too concerned with delving into this other aspect of it. It relates to this pointer. You know from Java that there is a special variable, I suppose you'd call it, called the this variable. JavaScript has a this variable as well. It's kind of a global variable, if you like, but it's a very error prone in terms of its usage. Well, sorry, it's not error prone. It can be the source of errors in your code if you're not fully aware of what this variable is pointing at. What it's pointing at changes dynamically, and you need to be aware of those changes if you are using this variable in your code. I don't think at any stage now in any of the JavaScript code that we use throughout this module will we have a cause to use this variable. We may when we start looking at the back end code, but not in the front end. So that's why I'm not too concerned in covering it. But it was a major headache for a number of years for programmers because they were using this, thinking that it was pointing at one object, whereas in fact it was pointing at another object, and hence their programs crashed. The arrow function that was introduced in ES6 cleaned up the problems that this variable was causing. No more, I'm not going to say any more about it other than that. All I'm saying here is that it gives you a cleaner syntax, but there was more to arrow functions than just cleaning up the syntax. The syntax of the arrow functions looks like this. So the actual keyword function doesn't appear at all. So you have your parameter list, your arrow, hence the name. The arrow kind of separated your parameter list from the body of your function. You still need the curly braces to wrap the body of the function, as was always the case. Down here, I'm saying that some of this syntax is actually optional. For example, if your function requires only one parameter, you can actually then leave out the parentheses. So there's just physically less typing to do. If the function is a single line function, if the body is just a single line, and we had one case of that on the slides, and that single statement is the return value of the function, then you can actually drop the curly braces and you can drop the return keyword. So all of those are optional in certain circumstances. And to be honest, it's not until you become comfortable writing JavaScript and you write a lot of JavaScript that you find yourself taking advantage of those optional parts to arrow functions. You may well find yourself writing all of the syntax, even though you may not necessarily need it in some cases. And I wouldn't worry about that really. So we can look at, before that, so if I go back to my code, I have an example of an arrow function. So this function notionally, it again takes a person object and it just returns a string, determines whether the person is male or female, and it returns a string prefixing that person's name with either Mr. or Miss, depending on their gender. That's all I could come up with. But from a syntax point of view, now based on what I just said, right, this function only has one parameter, so I could actually leave that out. Okay, it'll still work. In the body of the function, what am I doing? I'm just, again, it's always good to validate the parameters that are passed into you because of the nature of the JavaScript language. So I'm validating to make sure it is a person object. And here I am using the ternary operator. The ternary operator is not unique to JavaScript. It's available in Java as well. I don't know if you've used it. The way you interpret the ternary operator, you can notice the ternary operator because of this question mark here. So the way the ternary operator works is it takes this, what's before the question mark, it evaluates that from a Boolean point of view, if it's true or false. And if it's true, then it takes what's immediately after the question mark, and that becomes the result of this statement. If it's false, it takes what's after the colon. So what I'm really doing here is I'm checking to see what type of person was passed in. Was their gender male or female? And I either assign Mr. or Miss to this little variable here. I could have written that using a bog standard if-else statement, but the ternary operator is effectively a shorthand for writing an if-else statement, which you can use in certain circumstances. As I say, ternary operator is not unique to JavaScript. Pretty much every language has it. And then finally, here's my return statement. So I'm constructing a string template and I'm returning that string. So when I do console.log of salute me, then what I get back is, just save that. What I get back is this bit here, because it's determined it's male. So that's arrow functions, the 101 of arrow functions, if you like. So we can just go back there. Just pause for a second now in case there's any questions. Sorry, the code is here. No, okay, moving on. Oh yeah, I'm just showing you here. I've got another arrow function, again, based on the name. This function just determines whether a person has a middle name or not. But what's interesting is the body of the function just consists of one line of code, and that becomes the return value of this function. And because there's only one line of code, I've left out the curly braces. There's no curly brace here or closing curly brace. There's no return statement. So they were all optional. And in fact, yet again, I make mistakes myself. I can leave out the parentheses there. Okay, so that's taking advantage of all of the optional characters. Right, moving on. At the end of the day, arrow functions are converted back to function declarations, again, to ensure that all browsers can actually execute, because some browsers may not recognize the syntax of arrow functions. So we've got to give it a function declaration equivalent. There's a useful kind of website called the Babel.js website, which you can actually use it every now and again if you want to see what is the ES5 equivalent of a particular piece of ES6 code. We'll have cause to use this Babel.js website later on. I can't imagine you're going to be using it that much, but just to make you aware of it. So the website, I think I already brought it up. If you just go to our Google Babel.js, remember, Babel is this tool for transpiling ES6 back to ES5. And it has kind of an online tool. So what you can do is you can paste ES6 code in here, and it will show you the ES5 equivalent. Now, I was playing around with it earlier on. So here's my arrow function here. As I say, you can just cut and paste anything you want to in there. If I just paste in the other one, actually. this one here. The other thing just in passing is obviously any function that you assign to a variable, it makes sense that the variable is type const because it's not going to be changing. But if I copy that, you can see on the right, it's giving me the ES5 equivalent. No, it's not. I need to get rid of this here. Sorry. It's actually, it's assuming a default browser age, and the age that it's assuming is 2 new. So if I just get rid of that, then we can now see that my arrow function here just converts to a function expression. Sorry. Converts to a function expression in ES5. That's just kind of confirmation that there's, in one sense, there's nothing special about arrow functions. They're just a cleaner form, and arguably that's a cleaner syntax than this syntax here. Var is the equivalent of let. In ES5, the only way you could declare a variable is by using the keyword var. That was dropped because there were problems with the scoping of var variables, whereas let and const, their scoping is block scoped, as I mentioned the last day. That's all I'm documenting there, that babel.js.io website. Again, as I said, I can't imagine that you're going to be using it that much. Some other function characteristics. There is this notion of constructor functions, which was part of the language from day one. Now, the word constructor means something to you based on what you know about, let's say, the Java language. A constructor, as you know, is a method of a class for creating instances of that class. Constructor functions actually have the exact same role. They allow you to create instances of a particular object type, object in the JavaScript sense. And the syntax is slightly different. Well, it looks very similar to an ordinary function declaration. The way you invoke it is slightly different. Again, I'm not going to spend time explaining constructor functions because we never use them directly in any of our code, but just be aware of them, that they are there. And they actually serve the exact same purpose as classes in languages like Java. But of course, as you may or may not know, ES6 introduced classes to the JavaScript language. But when a JavaScript ES6 class is transpiled back to ES5, it's actually using this constructor function idea behind the scenes. So as we say, classes are not native to JavaScript at all. They're just syntactic sugar added on to the language, mainly to please the community that use the JavaScript language. Side effect here, I'm just introducing 1 or 2 programming terms which you may or may not have heard. I just took advantage of this slide to do this. Is not specific to JavaScript either. A side effect, if you've got a program that makes changes to variables outside its scope or makes other changes outside its scope, then we say that that program causes side effects. And that's what I'm kind of saying in this kind of pseudo definition here. It's when you modify some state being variables, outside its local environment being the scope of the piece of software, whether it be a function or a method of a class or whatever. And it's kind of argued that you should try and minimize the amount of code that you write that causes side effects. And the reason for that is it can be quite difficult to debug code which causes a lot of side effects. Sometimes you just cannot avoid it, but it's just something to be aware of. Be aware of the term side effects. What does it mean to say that a piece of software has a side effect? Illustrations of side effects and non-side effects. If you think of the add middle name function that I showed you earlier on, that function was passed an object. The object was actually declared outside of the function. but it changed the object. So we would say that the add middle name function has side effects or causes side effects. The salute function did not cause any side effect. Again, okay, it received an object that was declared outside its scope, but it didn't make any changes to that object. So hence, we would say it has no side effects. It's a final point, but any piece of code that generates IO, IO is considered side effects. And that's why I'm saying you can't avoid certain software or certain pieces of code causing side effects, because any piece of software is going to perform some IO, whether that be IO to the screen or IO in terms of talking to external services or whatever. Also, I'm just introducing the term pure functions. It's kind of related to side effects. A pure function is a function that has no side effects. And arguably, you should try and write as many pure functions as you like. Now, don't fret. I'm not going to be checking your functions to see how many pure functions that you have. I'm just giving you these terms just to add to your vocabulary, really. There's a branch of programming called functional programming, and some of you will be actually studying it in fourth year. It's a really interesting style of programming, and the idea of functional programming is to get you to write as many pure functions and functions that have no side effects, to write as many of those as possible within an application. So it's a very interesting programming paradigm. So that's kind of tangential stuff. Let's get back to JavaScript. Higher order functions. A higher order function is a function that takes another function as a parameter, or it could return a function as well. So this idea of functions returning other functions, that's not too far-fetched. It's we may come across it actually. In fact, we definitely will. Certainly, we will come across functions that take a function as a parameter. So if we refer to the function that's being invoked as the called function, and the function that's being passed into it, that's often referred to as a callback. Okay, so the callback is the parameter. And really what the invoked function does is it calls the callback at some point within its code. So again, the outer function, that might be a better term. The outer function is the function that contains a callback as a parameter. And what the outer function does is it invokes the callback somewhere within its body. Now, we will see a lot of use cases of higher order functions that are of that nature, that take callbacks. The syntax can be a little off-putting initially when you see a function inside another function, but you just need to get used to it, I suppose. At a very general level, so we're saying, and it doesn't have to be a function declaration. Now, you can use these higher order functions with arrow functions or function expressions or whatever. But the general idea is you've got a function, so I'm calling some HOF. It may have many parameters, but one of them is a callback. And we know now that a callback is a function as well. There are lots of examples that I could show you of these higher order functions, but there's a nice suite of them associated with the array data structure that I introduced the last day. So for example, the array has a method called for each, and it has a filter method, a map method, and a reduce method. And we'll just look at each of these, A, because they're interesting little functions or methods, I suppose, and B, because they all use this higher order function programming style. Let's look at the, here's the kind of an abstract illustration of the for each higher order function. So I've got an array. By the way, when I talked about objects the last day, I said that an object is a collection of properties. And I talked about objects in the context of data. but it turns out that a property in an object could be a function. So you could have a property, the key is whatever, but the value associated with that key could actually be a function. And we refer to those types of properties as methods. And you're familiar with the term method from other programming languages. So an object can have methods, where the method is a property of the object that is a function rather than a primitive value or an inner object. And so that's actually kind of, I might describe this here as, this is a method, i.e. it's a property of this structure. And we know what the way methods kind of work, right? So the syntax looks very Java-like, but even though it's JavaScript that we're looking at. So the term kind of function and methods can be used interchangeably. If you're talking about a function as being part of an object, as being one of an object's properties, then we can refer to that property as a method. Either way, summary.forEach, I'm calling this method stroke function. And the argument is this thing here. The argument is a function. And what the for each method does is it calls this function once for each element in the array. And you can do whatever you want to in the body of the function. Now, this is an example of, this callback is an example of an anonymous function. This is where we use anonymous functions a lot. We use them as callbacks to higher order function, because this function here doesn't have a name at all. Hence, it's an anonymous function. And as I said, what the for each does is it invokes this function once for each element in the array. And for each invocation of this anonymous function, what it passes into it are 3 arguments. It passes in the current element of the array that's being processed, its index position within the array, and it actually passes in the entire array. So this argument here is going to correspond to my full array up here. The last one is optional. You can leave it out if you want to. What you do inside the body, then it depends on whatever. So essentially what we're doing here is we're iterating over this array. And I said to you the last day that we don't tend to use for loops for iterating over an array. Instead, what we use is this for each method to iterate over an array. You can use a for loop if you want to, but this is a more commonly used approach. So there's a couple of things going on here. There's higher order function, the notion of higher order functions, the notion of callbacks, and the notion of anonymous functions. Back to my code. So I've got an array of numbers and I'm going nums.forEach. In this case, I'm using an arrow function as my anonymous function, and that's really the style that we tend to use today. We don't tend to use function declarations, which is what you saw on the slide. And so hopefully now we can interpret all of this. All I'm doing is a console.log inside in my anonymous function. So that's, and then down here. Okay, so this piece of code generates this output here. You can study that for yourselves, although maybe I'll just pause for 1 second in case there are any questions. No. Here's another example here. It looks like what I want to do is I want to count up the number of even numbers in my array. So, okay, declare an evens variable and initialize it to to 0. I go my nums out for each. I have my anonymous function or my callback, which again, I'm using the arrow function syntax to code my callback. And I'm using the ternary operator as well to determine whether the number is the current number in the array that's being processed is even or odd. This is the modulo operator in JavaScript. And finally, I'm console.logging. I'm console.logging. Well, sorry, what I'm kind of doing inside here is I'm incrementing this variable by 1 if I do find that the current number that's being processed is even. See, I'm doing a plus equals there to increment it based on the outcome of this ternary operation here. I'm either adding 1 or adding 0 to my evens variable. But you can study that in your own time. Now, I want to illustrate the other higher order functions associated with the array, which is filter, map, and reduce. And I came up with a little case study to illustrate these. The case study is fairly elaborate, but there's a reason why I'm doing it, and it's mainly to give you kind of a preview of what you will be doing when we start looking at the React framework. So let me just explain the background here now first. So there's this website called the randomuser.me website. And you can send it HTTP requests, GET requests. So you could send it a HTTP GET requests like this. And what it returns is randomly generated user profile objects, JavaScript objects. Here I'm asking it for 10 randomly generated user profile JavaScript objects. It returns them in the form of JSON, which is essentially just JavaScript objects. And we're going to use this random, I shouldn't be calling it a website really. It's actually a web API. Okay, it's an open web API that accepts HTTP GET requests of this form. So you've got to tell it in the query string, you've got to tell it how many randomly generated user profiles you're looking for, and returns that number to you as a JSON data structure. We could actually, if we bring it up in the browser, we can actually invoke it. Did I get it right? Oh, there we go. So here it is. And if I actually just grab that URL from the slides. It won't let me. So just 1 second now. Now, this is the response that comes back, but it's not very legible. So we can go to another website. This is essentially a JSON object data structure that was passed back. But I'd like to format it. So if I go to another website, I just type in format JSON. And so it's what we see it returns back to us is a JavaScript object with one key called results, and that key is assigned an array as its value. And in that array, there are user profile, what I'm calling user profile objects that are randomly generated. And you can see there, all of these kind of properties could potentially relate to a person. Okay, so that's going to be, if you like, our data source for this particular array, this results array. That's going to be our data source, my data source for demonstrating the other array higher order functions that I want to show to you. So that's the background, and this is what we want to set up for ourselves. It's pretty elaborate, but so the way you interpret this slide or this picture is, I'm going to have an ordinary web server, and it's going to be my live server, web server that I've plugged into VS Code. That server is going to send HTML and JavaScript down to my browser. And we've been doing that all along, actually. The HTML has very little in it. The JavaScript is where all the action is. But it's going to send that down to my browser. Now, in this case, the JavaScript is going to run in the browser as always. And what it's going to do is send a HTTP request to my random user web API. That's going to return an array of user profiles. And then I'm going to process that array and output something to the console, to the browser's console. Okay, that's what each of the subsequent little examples that I'm going to look at, they're all going to have the same architecture, if you like. What we need to find out, though, is how do we get a piece of JavaScript code to send a HTTP request to a remote web API? Because this is going to be a HTTP request. It's going to be an asynchronous type of communication, as in the response is going to come back sometime in the future. So we need to build all of that into our code. But not surprisingly, it's a very common requirement of your JavaScript running in the browser. So there's nice, clean solutions to it.